The BC Institute of Technology, located at Willingdon and Canada Way in Burnaby, has more than 1,600 full-time faculty and staff, and approximately 16,000 full-time students, at an average age of 22 years old. A fire tube boiler exploded on campus on April 13, 2004. Amazingly, only minor injuries to 7 people were reported. Here are the summary of events. The boiler was a fire tube steam boiler, manufactured by Cleaver Brooks in 1962. It was designed for a maximum allowable working pressure of 150 psig. It was installed at BCIT in December 1969, where it was used for instrumentation instruction. Between 1969 and 2003, the boiler was inspected by inspecting power engineers from Safety Engineering Services Division, Ministry of Community, Aboriginal and Women's Services. Inspection records indicate that the inspections carried out were typically internal and external visual inspections, a test for safety valve function, and a pressure test. Ultrasonic testing was carried out in 1993 to examine limited areas of the shell around the handholds. On April 13, 2004, the boiler was used for an instrumentation class to demonstrate safety interlock testing, combustion testing, and boiler combustion tune-up. The boiler, controlled from a remote control room, was in operation until approximately 13:50 p.m., when it was prepared for shutdown. While the instructor was proceeding to the boiler room to shut the boiler down, the explosion occurred. The boiler and the building housing it were destroyed. In accordance with the requirements of the regulations, the provincial safety manager was notified of the accident by BCIT staff. BC Safety Authority staff were present at the accident scene by 3:15 p.m. Emergency Response Services, RCMP, WCB, and BCIT security staff restricted access to the area. No access was permitted to the incident scene, and it could only be viewed from outside a perimeter set up by Emergency Response Services. BC Safety Authority staff informed BCIT security of their presence and made themselves available to assist as needed. Bacon Donaldson Consulting Engineers was engaged by the Ministry of Finance Risk Management Branch to investigate the accident April 14, 2004. Between April 16, 2004 and June 15, 2004, the accident scene was examined, decontaminated, and debris removed. The site was extensively photographed by WCB, BCSA, and BCIT staff. Physical evidence was collected and decontaminated by restoration company workers doing the site cleanup. The investigation was led by the WCB, supported by BCIT facility staff, who directed asbestos cleanup and structural assessment. 7 minor injuries were reported: 4 students, 2 security guards, and 1 instructor. The boiler was housed in a small single-story building adjacent to the plumbing building N6. The boiler house was a concrete block building of slab-on-grade construction. The roof was supported on steel beams. 2 walls of the building, south and west, collapsed outwards, and the roof was destroyed as a result of the explosion. Debris was scattered throughout the immediate vicinity of the boiler house. The safety valve was located a considerable distance from the site of the explosion, in an industrial area east of the campus. Damage to the boiler was extensive. It was displaced off its moorings, and the boiler shell torn from the tube sheets to completely expose the fire tubes. The burner and vent were dislodged from the boiler. Structural damage to the boiler room and asbestos contamination, as well as the extensive damage to the boiler and its associated equipment, constrained the on-site investigation. Specialized testing and analysis of the boiler material was required to establish the cause of failure, and therefore the findings pertaining to the probable cause of the failure are those from the Bacon-Donaldson report. The following is a summary of their findings. There was no evidence of design, material, or manufacturing defects that contributed to the boiler failure. The cause of the boiler failure was a crack that developed in the toe of the longitudinal weld seam of the shell from corrosion fatigue. The welded area of the shell is subject to stress concentration, and slight differences between the composition of the steel in the weld and that of the shell make this area susceptible to corrosion. This boiler was used for teaching demonstrations, operating only during instructional periods and then shut down for repeated periods. These intermittent operating conditions resulted in frequent cycling from startup to full operation and shutdown. During shutdown, air was drawn into the boiler, introducing oxygen into the boiler steam space and water. Procedures to remove oxygen from the boiler system by chemical water treatment were limited. A deaerator was not used to remove air from the feed water. Corrosion due to oxygen attack developed in the welded area, and stress fluctuations from the cycling initiated a crack which grew to a critical length, at which point the shell ruptured. The failure was a result of deterioration of boiler shell caused by adverse operating conditions.